The Oklahoma City Data Center, located at 4442 Newcastle Road in Oklahoma City, is 66,715 square feet. Upon completion of construction, it was awarded the LEED Silver NC. Approximately 95% of the facility is rated to withstand an F5 tornado, with both structural and mechanical hardening components. Structural components consist of 12-inch steel reinforced precast concrete panels, reinforced steel hurricane louvers, and reinforced steel grating. Automated mechanical components consist of storm dampers, steel wind doors, steel blast doors, and a rolling storm closure gate. The administrative area, at approximately 4,000 square feet, is the only area outside of the rated structure. The administrative area is comprised of 6 offices, a conference room, men's and women's restroom, a combined break room and utility room, an open office area with 11 assembled workstations. The north entry corridor is protected by a security blast door, fortifying the north perimeter opening. Additionally, the west security wind door fortifies the west administrative area entrance. Both doors are triggered to close by the automated storm sequence. The fire pump room is located immediately within the facility's north main entrance. Within the fire pump room are found the fire alarm control panel, monitored by a General Electric EST3. A fire control panel with an auto transfer switch provides utility power protected by a generator for the fire sprinkler pump system. System pressure is maintained by a fractional horsepower jockey pump and supported in the event of a release by a 25 horsepower fire pump. 2 types of dry systems are supported by a nitrogen generation system. This nitrogen generation system was installed in 2017 and replaced a compressed air system. This was introduced to the facility to reduce moisture developing within the pipes. This will reduce corrosion and the potential for freezing in mechanical areas. 2 types of dry systems are supported by the nitrogen generation: a pre-action system and a dry system. There are 3 pre-action zones that cover the data halls, UPS rooms, switchgear rooms, and the paralleling gear room. The dry system covers 3 zones, including lower level mechanical, the 3 air-cooled chiller platforms, the generator rooms, and the loading dock. A single wet system with 1 zone covers the administrative office and the corridor. Located within the data hall corridor surrounding both data halls are 8 computer room air handlers. These air handlers provide supplemental conditioning to data hall number 1. 2 of the air handlers have reheat and humidification capabilities. There is an additional air handler in the corridor that serves data hall number 2. This unit also has reheat and humidification capabilities. raised floor space around the data halls is monitored for leak detection. This leak detection is in addition to the leak detection provided by the in-row coolers within the data hall. The leak detection has been mapped out for quick identification of the leak detection and location. Accessible from the data hall corridor are the data halls, UPS rooms, switchgear rooms, generator rooms, the loading dock, and the East Administrative Office area. An East Security blast door protects the integrity of the data hall entry from the east side of the administrative area and maintains the rated structure. There are two UPS rooms, A and B. Each contains a UPS system that consists of one MGE static switch cabinet and three MGE UPS modules. Each UPS has 240 valve-regulated lead-acid batteries that produce 750 kVA. This is 675 watts of power at 480 volts. As the data halls are conditioned by multiple computer room air handlers, each UPS room is also conditioned by 3 air handlers. At full capacity, 2 air handlers are capable to satisfy the load, with 1 in standby in each of the UPS rooms. Utility power is provided by Oklahoma Gas and Electric, where 20,000 kVA is delivered to the property from 2 separate substations. 10,000 kVA has been brought into the building. The other 10,000 kVA is delivered to existing pads in place, ready for build-out of a second phase. 4 switches are also on these pads, and they are in place to allow for isolation as well as the tying together of feeds to the building performed by the utility provider. 4 transformers are located at the property where voltage is stepped down from 12,400 volts to 480 volts. 2 of these supply power for the IT load and 2 for the mechanical. Pads are also in place for future transformers, with conduit and meter bases in place for a future second phase. There are 2 main switchgear rooms for feeds A and C and feeds B and D. Included in each switchgear room are the following components: main circuit breakers and cabinets for each of the 4 feeds delivered to the property from Oklahoma Gas and Electric. Closed transition transfer switches supported by the OG&E utility feeds, as well as the feeds from the generators. Lastly, Square D distribution switchgear distribute the IT and mechanical power to the downstream distribution. Future conduits for E and G and F and H main circuit breaker, closed transition transfer switches, and distribution switchgear also exist. Additionally, within the A and C switchgear room are a UPS supporting emergency lighting and exit signs, as well as a charging station for spare batteries for the main UPS modules. These charging stations hold up to 30 spare batteries for the UPS. The paralleling gear provides the main control for the emergency generator power. This gear monitors utility power at the 4 closed transition transfer switches, as well as the auto transfer switch for the fire pump, and will call for the generators to start in the event a loss of power is identified. The paralleling gear will manage the running of the generators as needed to maintain the load, and the shedding of a generator if reduced load is measured. Within the electrical room for the paralleling gear is the load bank controller and breakers that allow for generator load bank testing and the UPS battery discharge testing. The 2 megawatt load bank is on site and connected to the various sources of power through a Kirk key lock system. The load bank can test power supplies from 5 to 2,000 kilowatts. In the event of a loss of electric utility, the facility has 3 2 megawatt generators and additional space for the installation of an additional 3. As mentioned earlier, automated storm dampers are in place to protect the generators. In the event that a tornado was detected, these dampers would close. 3 100-gallon day tanks hold and pump fuel to each of the 3 generators. The generators have dual starters, dual sets of batteries and chargers, double fuel filtration in addition to filtration upstream. Hurricane louvers protect the air intake for the generators and sit in front of the storm dampers. Discharge areaways are protected by steel reinforced grating. These sit downstream of additional storm dampers. In the event a tornado was detected, these dampers would also close. Two 15,000-gallon underground storage tanks provide diesel fuel oil to the generators. Each tank has 2 submersible pumps where fuel can be transferred from one tank to another with or without filtering through the fuel filtration master control panel. A Vita-Root monitoring system maintains monitoring and record keeping for fuel levels, water contamination, and leakage in the fuel system. The water-cooled chiller plant is located in a below-grade area of the facility. In addition to the 2 350-ton water-cooled chillers, this plant consists of multiple components utilized for the generation of chilled water. There is also sufficient space for the installation of an additional chiller. A Polaris heat exchanger is available and utilized when external weather conditions allow for the efficient and economical production of chilled water with the use of the condenser water system. 3 condenser water pumps support circulation of condenser water to and from the cooling towers. A sand filter assists in keeping the water and cooling towers clean through constant filtering and regular backwashing based on time and differential pressure. Regular water testing can be performed at a local water treatment testing station. Chemicals are introduced into the chilled water and condenser water systems to prevent microbiological growth, corrosion, and scaling. A chlorine dioxide biocide is introduced into both chilled water and condenser water systems and helps remove biofilms. Primary and secondary chilled water pumps located in the chilled water plant work in concert to maintain differential pressure both through the chillers and to the various cooling units in the data halls and throughout the facility. 3 350-ton Marley cooling towers assist in rejecting heat from the water-cooled chiller return water to the air. These towers sit above the chilled water plant on a raised platform on a lower roof. All pumps and fans operate on ABB variable speed drives for efficiency and equipment protection. An 80,000-gallon thermal storage tank maintains chilled water and is an active component of the circulation of the primary chilled water. This large volume of water will be utilized in the event of the activation of the storm mode. While the building management control system, Allerton Compass, is available at local desktop units in the administrative area and available through remote connectivity off-site, a control room resides in the hardened structure adjacent to the air-cooled chillers and exterior cooling towers through a perimeter door. This is an ideal location for system utilization during a weather event. This room can also be utilized for routine programming, equipment management for maintenance, and monitoring. Although the water-cooled chillers are the primary source of chilled water at the property, standby air-cooled chillers are available for redundancy as well as for the use in the event of a triggered active storm mode. Similar to the emergency generators, intake air storm dampers are in place to protect the overhead area above the air-cooled chillers. In the event a tornado is detected, these dampers would close. Below the chiller and in the below-grade area adjacent to the water-cooled chiller plant are the discharge areaways for the air-cooled chillers. Discharge air forced from the air-cooled chiller push through the barometric dampers and are forced to the exterior of the property through discharge areaways. These are also protected by steel reinforced grating. In the event the air-cooled chillers are operating and the internal fans cannot maintain an adequate head pressure, 4 velocity fans per chiller are available to increase the velocity and volume of air to reject the heat from the air-cooled chiller refrigerant. Discharge air storm dampers are also present in this air chamber. In the event that a tornado was detected, these dampers would also close. Similar to the water-cooled chiller plant, an additional air-cooled chiller bay is available for the installation of a future air-cooled chiller. The automation process for the storm sequence is initiated when a locally read pressure sensor reads a low atmospheric pressure or a rapid drop in atmospheric pressure and will cause the data center to go into an active storm mode. During an active storm mode, the following will occur. Any chiller in operation will shut down. All storm dampers will close. If generators are running, they will also shut down, and the chilled water cooling will be supplied from the thermal storage tank. If available, the data center will remain on utility power. If not, the IT load and select mechanical equipment will be supported by the UPS. Likewise, emergency lighting and exit signs will be powered from an independent UPS. Wind doors and blast doors will automatically close as well. Chilled water will be supplied for the duration of the active storm event from the thermal storage tank. When atmospheric pressure returns to normal, dampers will open and the air-cooled chillers will be started, and provide primary chilled water generation. Generators will also be enabled and will be able to start if needed. Wind doors and blast doors will require manual opening. Water-cooled chillers can only be re-enabled manually due to the required verification of the operable status and condition of the exterior cooling towers.